Looking at number 1, let's see, hold on. Pause start then. Okay, so looking at number 1, you're just trying to find which number line below correctly plots 2 and 3/8. So we only have the option between 2.2 and 2.5. So basically the problem is that we have fractions there and these have decimals. So what we want to do is take this 3/8 and we got to change it. So I'm going to zoom in. And basically this 3/8 here, I need to change to a decimal, so I'm going to write in and out to remember how to put it in a decimal. Yep, what goes inside? Oh. So we put the in and out so we can remember what goes inside. What goes inside?
3.
Very good. What goes outside? 8. And now you have to add what? Okay, 2 zeros and the decimals. Very good, guys. 8 goes in 3 how many times? 0. 8 times 0 is 0, so we don't have to do that. 8 goes in 30 how many times? 8 times 4 will be 32, so it's a little bit over. 3 then. 8 times 3 is? Oh, try again. 24. So what is 30 minus 24? What is 30 minus 24? So I'm going to pause the video and then you work the rest out. See if you got. So you said 30 minus 24 is 6. Bring the 0 down. 8 goes into 60. Did you find out how many times? Let's see. 8 times 8. That would be 64. So it's 4 over the 60. Okay, let's try 7. 8 times 7 is? Almost 50. Subtract 8 from here. No. Subtract 8 from 64. So 8 times 7 is? 56. 60 minus 56 is? Okay, so borrow from the 6, 5. What is 10 minus 6? 4. 5 minus 5 is 0, so 4 is your remainder. So we're going to stop at 0.37. Now remember, we just did the 3/8 part, right? So I'm not looking on the number line and trying to find where's 0.37, right? So where am I trying to find it? So it has to be 2 and what? 2 point what? 2.37. Right? Remember, because I only was paying attention to this part when I divided, which is why I only got the decimal, but it's definitely going to be 2 for the whole number. Let's change the color so we can match this up. So this 2 here came from, this 2 here came from this 2 right here. Good? Now we got to find 2.37. Let's look for, on A, B, C, D, which answer is definitely wrong. So instead of trying to look for the right answer, which one do you know is wrong so we can cross it off?
C.
Okay, so this one lands right on 2.3, so it won't be that. What else? D, you think that one's wrong because it's below 2.3, so it's like 2. What is that, 2.8 or something? Okay, so D. Okay, so now we're down to A and B. Which one looks like it's 2.37? Okay, so it's closer to 2.4. This one here would be 2.5, right? So this is probably like 2.4, or sorry, 2.35. Let me erase that. So this one's about 2.35. Good? Okay, so this one won't be good here. Actually 3.4. Let's see. Let me zoom in so we can make sense of why it's like that. So this is 2.3 here. Basically, you break this up into another 10. So here would be 2.35 right on this part. So this would be 0.4, 0.3, 0.2, 0.1, or 0.0. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So notice how I can break it up into 10 lines. All right, so we know B is not an answer. So your answer, as you were telling me, is A. So this looks like 2.37. So basically, this again was 2.35 here. And then this would be 6, 7, 8, 9, 10. So, are we good with this? Yes. Okay. All right, next one. Which of the following expressions is equivalent to 16 over 24? So let's look at the answers and we'll see what they want us to do. Okay, so basically you have things that you're going to work out and you're going to see which one's equal. All right, I'm going to pause the video to try this out before you watch the video. Okay. All right. So you guys are good? All right, let's talk about it then. So this would be 1 over 6 times 4 over 1, and you just multiply across. What is 1 times 4? 4. What is 6 times 1? 6. So we have 4 over 6 here. We're looking for it to be equivalent of 16 over 24, right? Is 4 over 6 equivalent to 16 over 24? Now, before you answer, you have to think, because this is a smaller number than this one, right? So we have to think about something. Is there a number that I can multiply the top and bottom by to get 16 over 24? Okay, so let's see. If I do 4 here, I'm going to do it in a different color so we can tell what I'm doing. So times 4. Did I get 16? Now, if you times the top and bottom by 4, you're really multiplying by 1, so it's the same thing. 4 times 6 is? So is this one equivalent? Yeah, because remember, multiplying by 1 is, it doesn't change the value of it, it just changes how it looks. You remember that? So it's basically like if I had a pizza here and I have 1/2 and shade this in. I could also have, if I multiply by 2 and 2, this would be 2 over 4. And the pizza slice would just have more cuts to it, but it would still be the same amount shaded. If I multiply this by 2, this becomes 4 over 8. And now the pizza just has more cuts. So you have to cut it into 8 slices. Right? And then we still shade same amount. Okay, so this one is an answer. Let's go to the next. This you have to remember to keep, change, flip. Keep, change, flip. So this will be 2 over 4 times, and then 12 over 4 would flip. So what that means is this goes below and this goes above. So this becomes 4 over 12. So keep, change, flip. Now, on this, you're going to multiply across. 2 times 4 is 8, and 4 times 12 is 48. Can you reduce it? Yes. To what? What could you divide top and bottom by? 8. Okay, let's try 8. Okay, how many times does 8 go into 8? 1. How many times does 8 go into 48? 6. Very good, 6. Okay, so this is 1 over 6 here. Now 1 over 6, is there any way I can change this to 16 over 24 by multiplying top and bottom? Okay, well think of it this way. What do I multiply to get 24 on the bottom? 4. 4. So I would have to multiply the top and bottom by 4. So if I multiply across, this would be 4 over 24. Did that give me the 16 over 24? No, so B can't be an answer. Okay, go to 3, or sorry, C. C is going to be 2 times 8 and 24 times 24. Okay, this will be 16 over some huge number. Do you think that you're going to be able to reduce it if this is already 16 now? No, so instead of calculating what 24 times 24 is, we could save time because we know we definitely can't reduce it to 16 over 24 if this one here is already 16. So C can't be an answer. D, what about D? So we're going to do keep. What do you think? Flip. When do you do keep, change, flip? When you have a, what sign? When do you do keep, change, change? When you have a, okay, so don't confuse the two. So if I have something like this, subtraction, I do keep, change, change. This is when I do division. So let's erase that. All right, now 24 divided by 24, we can make this a lot easier than it looks. What is, there we go. Already heard the answer. 24 divided by 24 is 1. Divided by, now 16 over 24. We can reduce it or we can leave it like this, then do keep, change, change. Do you see what we could reduce it to? What number goes into 16 and 24? 4. So I'm going to divide by 4 here. 4 goes into 16 how many times? 4, and then what's on the bottom? 6. So there's a bigger number, right? We could also divide by 4 again, and then we could do 1 divided by 2 over 3. So I'm going to write it over here because I ran out of room. And now we are ready to write keep, change, flip. When do we use keep, change, flip? Very good, when it's division. So we have 1, change division to? Very good. 2 over 3 is? 3 over 2. So this becomes 1 over 1. I'm going to erase this and change it as 1 over 1. So just for looks, that way you know what the numerator is, denominator. Are we good that 1 over 1 is the same as 1? Yes. Okay. What's 1 times 3? What is 1 times 2? 2. Is there anything I can multiply this to get 16? Oh, hold on. Get 16 over 24 over here because I'm trying to find the equivalent? No. So is D an answer? No. Your only answer, therefore, is A. Okay, Leanne says that 0.58 is a rational number. Is she correct? Why or why not? So we have to just know the definition of a rational number. A rational number is a decimal that ends. Okay, and the reason why it's a decimal that ends, like let's say I could put 0.33, right? And it ends right there.
Mrs. Wilson, please contact the office.
So basically, since it ends, I can write it into a fraction. So anything I can write into a fraction is a rational number. So you know how this is tenths? And this one is hundredths? And then the next one would be thousandths? Okay, so since this is in the hundredths, can't I just write 33 over, do you remember? 100, because it was in the hundred spot. Okay. The easier way to think about it is how many spots, how can I say this? How many digits after the decimal are there? 2. This tells me how many zeros I need. So let's say, and I don't know my word for this one, and I put 3, 5, 6, 4, 7, 8, 9, right? Do I really want to say tenths, hundred thousandths, 10 thousandths, 100 thousandths, 10 hundred thousandths, or whatever it would be after this? All I would need to do is 3, 5, 6, 4, 7, 8, 9, and then start counting. 1, 2, 3, 4, 5, 6, 7, and that tells me I need this, and 1, and 1, 2, 3, 4, 5, 6, 7. So how many after is what tells me how many zeros. You won't have a problem like this, but that's just to illustrate my point that it's about the zeros. Yeah. Now, back to what we're trying to figure out is what is a rational number. So a rational number from this example is anything that can be written as a fraction. So she says that 0.58 is a rational number. Do you think she is right or wrong first before we go into the reason? Yeah, she's right because we can write it as a fraction, right? Now, A and C have that, so D or B and D are definitely wrong. So we can cross those out because it is a rational number, but now we got to compare the reasons. So a terminating decimal would be when it ends. So if I do something like 1 over 3 and I do my in and out, or you put it in a calculator, right? This will be 1, 3.0000. 3 goes from 1 0 times. Into 10 3 times. That's 9 minus 1. Bring the 0 down. Goes into 10 3 times. 10 minus 9, 1. Bring the 0 down. Just keeps going on and on. And you can put a bar above to show that it goes on and on. So this would not be a rational number because it's a non-terminating decimal. Right. Okay. So here, 0.58 is a rational number because it has a terminating decimal. 0.58 is a rational number because it doesn't have a repeating decimal. So which is the reason? So on here, C would be your answer, yes. So here's the trick about this though, because we said if it could be written as a fraction. Now this is where it gets tricky, so pay attention to this part. 1 over 3, if I gave you 1 over 3, you could say, yeah, it is a rational number because it was written as a fraction. Good so far? Yeah. But if I gave you 0.333, this part right here, you would say this is not a rational number. Even though I divided 1 over 3 to get this, the fact that it's a non-terminating decimal, you would say that it is not a rational number. So it depends on what you start with. So if I have 0.33333 and it goes on forever and that's what I gave you, you would say this is not a rational number because I wouldn't be able to represent this as a fraction. Okay. So, but this right here, you won't be asked that in depth on it. Okay, one batch of cookies requires the following ingredients. Let's erase this so I have room. Okay, Eric wishes to triple the recipe. Triple, what kind of number would that be? 3. Okay, so we know we got to do something with 3. How much of each ingredient should he use? So there's, if you're going to triple it, imagine that you're really making the cookies, right? And let's say there's 1 cup of something. If I triple it, how many cups would I use? Say it was sugar. How many cups of sugar if I'm tripling the recipe? 3. So you know it's 3, but how did you get 3? What operation? In your head, did you do 1 cup plus 1 cup plus 1 cup? Okay, so we're going to do multiplication. That's important that you start off with something easy to make sense of this, because you're going to want to say 2 and 1/3, right? 2 and 1/3, and then you want to multiply by 3. So how much of each ingredient should he use? Now we don't have to go through and find each one first. We can work smart and we can start it by which one is correct, A, B, C, or D. So let's look at flour. We know we want to do flour. 2 times 3 is what? 6. Now would I just say 6 and 1/3 is your answer? No, you're forgetting to multiply that third by 3, right? So we're going to have to add 2 and 1/3 plus 2 and 1/3 plus 2 and 1/3. So you know that you're multiplying 2 times 2 or 2 times 3, and you'll get the 6 part. What should be this? What's the numerator? Very good. So what's your real answer then? 7 cups. Very good. Okay, so is A correct? No. Let's go on to B. Chocolate chips, 3 over 4 times 3. Now, when you're multiplying by 3, it helps if you make it into a fraction. Now you just multiply numerator with numerator, denominator with denominator. I'm going to pause the video, try that out now. I would say that. Okay, So now let's look at the next one. I'm going to erase from the first one so I have some room. We know it's going to be by 3. So for this next one, we have 3 over 4, multiply by 3, but make it over 1. If you multiply across, you get 9, multiply across, and 4. So let's see how they wrote the answer, because based on the answer, I'll know if I need to divide. Because 4 goes to 9 how many times? 4 into 9 how many times? 2. So 2, and then what's left over? 1 over 2. Has to be the same denominator. You can always check your answer by multiplying and adding and seeing if you get back to 9 over 4. 4 times 2 is 8. 8 plus 1, 9 over 4. So it's a good habit to get into is multiplying it back. Okay. So 2 1/4. Does that look like it'll reduce to 2 1/4 for the chocolate chips? 9 over 12? You definitely know it won't be a whole number if the the numerator is smaller than the denominator, right? Because this means I would cut it up into 12 pieces. I don't even know how you would cut it up into 12 easily. That's gonna look horrible. But basically, you would cut it up into 12 pieces. So let's do a rectangle. So this would be half. 1, 2, 3, 4, 5, 6, 7, 8. This is harder. Okay, imagine there's 12 pieces. You'd only have 9 on here, right? And then 3 left. So this would be 9. This would be 3 over here. All right. Does that look like it's going to be wholes? Because remember, we got 2 1/4 as the answer. Does it look like it's going to be a whole? No, so I know right away that this won't be an answer because this is below even 1 cup. That's less than even 1 cup. Next one, 2 over 5 times 3 over 1. Multiply across, multiply across. What's 2 times 3? 6. What's 5 times 1? 5. Okay. 6 over 5 cups of chopped almonds. Yes? Very good. C is your answer. What about D? D says 2 1/2 cups of brown sugar. So you have 1 1/2 cups of brown sugar, and then we're going to have to multiply it by 3. Okay, remember on this one, when you're doing the mixed fractions, you have to multiply the whole and the fraction if you keep it in this form. If you don't like doing that and you notice you make a mistake, change this to an improper, please. 2 times 1 is 2 plus 1. This is 3 over 2. Now that you have the 3 over 2, multiply it by 3 over 1. So what is 3 times 3? 9. What is 2 times 1? 2. 2 goes to 9 how many times? 4. Because that will be 8. 4 and what? 4 and 1/2. Or you could go to this. This is your first way. I'm going to show you the second way if you don't change it to improper. 3 times 1 is? 3. 3 times 1 here, though? 3 over 2. Now, this one, 2 goes to 3 how many times? 1. And then what's left over? 1/2. 3 plus 1? 4 1/2. So there's 2 ways here. I think this one is easier. Which one do you guys like better? You like the second way?
I like the second way, but I'm used to the first one.
Okay. The second way, I feel like you're doing a lot of mental juggling about things on here, because then you got to remember to put a plus sign
Ms.
and all
Gunther,
this.
please contact
So
the
and then
office.
you have the 1 here, the half. I don't know, but at least you have 2 ways. Figure out which one you're really good at. That way you can get it right on the test, though. I really think first way is easier, but that's just me. Yeah. Okay, so is 4 1/2 cups of sugar right? No. Okay, so your answer was C for this Okay, go to number 5. Which decimal is equivalent to 19 over 50? Which decimal is equivalent to 19 over 50? How do you change a fraction to a decimal fraction? You divide. Okay, so then you have to divide. So we're going to have 19 over 50 here. What's your favorite hamburger place? In and out. What goes inside? Ooh, 19. Remember, that's the point of saying in and out. 50 on the outside. Okay, I'm going to switch to blue. What should I put? Okay, just one. What else? Awesome job. Okay, so 50 doesn't go into 1. 50 doesn't go into 19. We good? What about 190? How many times? 3. What is 50 times 3? Very good. 3 times 5 is 15. Tack on the 0. So this gives you 40 as your difference, and bring down your 0. 50 goes into 400. Think of it this way. 5 goes into 40 how many times? 8. So what is 50 times 8? 400. Okay. 0.38. 0.38. C. That one was a lot quicker to do than the others because we don't have to do every single one. Okay, number 6. What is the value of the following expression? Negative divided by negative is what though? A positive. Go through and mark off all the answers that won't be positive. Okay, which ones did you mark off? Alright, A and B can't be an answer because your answer is definitely positive. Knowing that the answer is positive, we could even rewrite it as 81 over 9 to make it easy. We're not even looking at signs anymore because we know negative divided by negative is positive. How many times does 9 go into 81? 9 times. What if you didn't know? What would you work out? You would divide. So this isn't only for decimals because this is also whole numbers. So if this was a hard problem for you, you put 81 on the inside, 9 on the outside, 9 goes into 8, 0 times, 9 goes into 81, 9 times 81 minus 0. Okay? But if you know your multiplication tables, you probably wouldn't have to do something like this. Okay, C is your answer for that one. Go to 7. You're going to solve 7 divided by 7 over 11. What should I use when I see division? Yeah, it is reciprocal. I like that word. Oh, good. Keep change. Flip. I would put an R, but at this point I've said flip so many times I think you'll confuse. We switched it right before the test. But you could say keep change reciprocal. Reciprocal is the academic word for flipping it. So we're going to take this 7, bring it down, take this 11, put it up. So this becomes 7 over what?
7 over 11.
No, 7 over 1. Yeah. And then change this to multiplication, 11 over 7. We good so far?
Yeah.
When do you use keep change flip? When you divide. When do you use keep change change? Okay, very good. What is 7 times 11? What is 1 times 7? 7 goes into 77 how many times? 11. Which one is your answer? A. Please notice the way that I do these problems is I do not look at the answers unless it calls for that, like which one is true. But I work it out completely, then I check the answers. I wasn't even paying attention to the answers before. Okay? But sometimes they try to trick you and you have one more step to do and they put that answer down and they'll say simplest terms. And you'll pick something like 77 over 7 when you should have picked 11. So you got to be careful about that. Which number line below correctly plots 1 and 2 over 5? So it's to a decimal, so how do I solve this if it's on a decimal? Yes, so I'm going to have 2 over 5. In and out. I'm going to show you two ways for this one. First, we're going to do it our typical way. 5 goes into 2 how many times? 0. 5 goes into 20 how many times? 4. 5 times 4 is 20. Subtract 0, bring it down 0, so we can put another 0 if we wanted to. So this becomes 1.4. Very good. Now for 1.4, which one do you think it is not? Let's start by which one is definitely wrong. Okay, let's look at A. We were saying this one's definitely wrong. So 0.4. Yeah, I would say that's wrong. You're looking for 1.4. Alright? So all they did, look how they tried to trick you. They put just the 0.4 you get from dividing. If you forgot to put the 1.4 and you got excited like, I saw 0.4, and then you put this answer, you would have been wrong. So you have to take your time, think about, go back to this, and maybe make a habit of just writing it right above it. Because you would catch, oh, 0.4 is the same as 1 and 2. So A is definitely not an answer. What else is definitely not an answer? B? Okay, B is at 1.2. Okay. C, 1.2 and 1.3 is in between somewhere. Is that an answer? Okay, so it has to be D. Yep, it's right at 1.4. So D is your answer. Okay, next one. Jordan has 12 feet of lumber to make wooden signs. If each sign requires 2/3 of a foot of lumber, how many signs can he make? Now, the purpose of having this problem, you won't have something exactly like this on your test. The biggest thing is, do you know what operation to use given 12 and 2/3? So basically, is this a multiplication problem, addition, subtraction, or do you think it is a division problem? Let's say you said that each sign requires 2 feet of lumber. How many signs can you make given 12 feet? So we'll put the 2 here. So I'm replacing it with a much easier number. How many signs can you make given 12 feet of lumber, and each sign takes 2 feet? 6. 6 feet, or 6 signs you can make, right? What operation would you have to do? Divide. Please notice what I'm doing. I made the number so much easier to where now I can make sense of it. So all I'm going to do is go back, erase this, erase my answer here because this was when I was just trying to figure out what it's asking. And now I'm going to put 2 over 3. Didn't we just do a bunch of these problems? Okay, go ahead and solve. I will pause the video. Okay, so we have 12 divided by 2 over 3. Let's answer this. So I'm going to first change 12 to 12 over 1. We're going to keep that, change that, then flip. You always use keep, change, flip when you're dividing. 12 divided by 1 times 2 over 3 becomes 3, and then over 2. Sorry about that. Okay, so that becomes 3 over 2 here. So now multiply across. 12 times 3, 36. 1 times 2, 2. 2 goes in 36, 18 times. So C looks like it will be your answer. Read it one more time. Jordan has 12 feet of lumber to make wooden signs. If each sign requires 2/3 of a foot of lumber, how many signs can he make? So he can make 18 signs. All right. Let's let's go to 10 and 11, and then we will stop the video here. So which of the following is equivalent to 18 over 30? 18 over 30, you're going to use in and out to get a decimal, right? All right. I'm debating if I want to go over this one because you do need that practice. Let's see. 18 goes inside, 30 goes outside. Try this problem. If you don't get the correct, and then check your answer using a calculator after. Okay, so I'm going to leave this one for homework, just so then you have a little bit more to practice on, and you can just type it into your calculator and check your answer. Which of the following is equivalent to 4 over 9? Same thing, so you're going to do this one for homework. This is your in and out. Alright, and then we will have the rest of the answers in another video. So that's half of it, part 1.